Good afternoon, everyone, and welcome to the Johnson Space Center in Houston, Texas. I'm NASA's Sandra Jones, and we're here this afternoon to talk about Orion's upcoming entry into the moon's sphere of influence and the outbound powered flyby burn, which will help propel the spacecraft into its distant retrograde lunar orbit, following the historic liftoff of Orion atop the Space Launch System on Tuesday, November 16th. We're going to hear from a few folks off of the top today, and then we'll allow them to have some opening remarks before we have some question and answers on our phone bridge, as well as from media here in the room. So without further ado, I'm going to introduce today's briefers. First, we have Mike Sarafin, the mission manager for Artemis I. We have Geffre Radigan, flight director. Jim Geffre, manager of the Orion Vehicle Integration Office. Thank you all so much for joining us today. I know it's been a busy few days for you all, so we really appreciate the time. So to start off with some opening remarks, go ahead, Mike.
Well, good afternoon, and thank you for continuing to follow the Artemis program and the Artemis I mission. As Sandra said, it has indeed been a busy couple of days. In just 3 flight days, we've gone from the surface of the Earth to more than halfway to the moon. And we are setting up for a key decision gate tomorrow, which is to decide, as part of a pre-planned and a pre-mission decision gate, whether to enter the distant retrograde orbit. And to date, all the systems look favorable for that, but we're going to continue to gather systems performance information and data on the Orion spacecraft before making a conscious decision to commit to that distant retrograde orbit as part of the outbound powered flyby, which is the first of a 2-maneuver sequence. In terms of flight test objectives, as we talked prior to the mission, we have 4 primary objectives. Priority 1 is demonstrate the vehicle at lunar reentry conditions. Priority 2 is to demonstrate the vehicle in the flight environment. Priority 3 is to retrieve the vehicle, and priority 4 is what we call bonus objectives associated with science, technology demonstrations, and outreach to each and every one of you. We have completed the first half of priority 1 with the Space Launch System delivering Orion to the point of translunar injection and putting all of the kinetic and potential energy into the spacecraft, and now we need to take that out, and we will realize the second half of that objective on entry and splashdown day. Priority 2 and priority 4, we are 20% complete with the objectives. 26 of 124 objectives are already complete. We have 40% of the remaining objectives, or 50 of the 124 in progress, and then we have about 40% or 48 of the 124 remaining ahead of us. But overall, the mission in just 3 short days is proceeding and exceeding expectations. In terms of payloads, we did successfully deploy all 10 of the 10 CubeSats. We are getting reports from a number of the payload customers that show that half of them are successfully executing their mission. The other half are working through a series of issues with either intermittent communications or just some of the CubeSats themselves are having difficulties. One of those is a success story that we were concerned about prior to flight, which was the Luna HMAP CubeSat that we were concerned had a low battery state of charge. That one actually is on path to have a successful mission. The payloads on board Orion, 3 of the 4 that we have, we don't get any real-time telemeter data from. The bio experiment number 1, all that data is recorded on board and recovered post-flight. The ESA active dosimeter experiment, again, is recorded on board and recovered post-flight, as well as the Matryoshka Asco-Rad experiment, or MARI experiment, that is recorded on board and recovered post-flight. But the Callisto technology demonstration payload has checked out. We've checked it out through the Deep Space Network. We've had a Snoopy sighting in the cockpit, and we are setting up for the first guest event in the next couple of days, and I won't get in front of that and spoil that one for you. But I will have a bit of a spoiler alert on some Easter eggs in the cockpit. We do have some Easter eggs in the full view of the cockpit So when you do get that view of the cockpit, happy hunting, folks. In terms of just overall systems performance, we've met each and every day of the mission. We met the day of launch at 5 p.m. on the 16th. For about an hour, we saw some performance funnies associated with the star trackers that caused us to pull together an anomaly resolution team. And that anomaly resolution team has concluded. We concluded that today. And it had to do with what we call dazzling of the star trackers with thrusters and thruster plumes actually being picked up with these highly sensitive instruments. So we worked through that, and there was some great leadership by the Orion team and the folks that work with Jim Geffre and Jeff Radigan to resolve that one. On flight day 2, we did meet again as a mission management team for the first time here in Houston, and we met for just under 2 hours, and that was largely just get settled in, review the status of the mission. We did go through 13 anomalies and funnies. Most of those are relatively benign, or what I would call the team learning about the system performance and learning how to operate it in the flight environment or to interact between the ground and the spacecraft as we fly along. And then today we met to review the Orion spacecraft performance, and Jim will give you some highlights on it, but it is exceeding performance expectations, and it was actually fun to see the team come in and report on the Orion spacecraft performance. We did close out that anomaly resolution team associated with the star trackers, and we also celebrated a stalwart within the Orion program whose last day is today, Mark Kirsich, the former Orion program manager. So it was fun to see him share that moment where he got to recognize that his thumbprints are on the Orion spacecraft after his many years as within the program on his final day as an NASA employee. So that was a fun thing to share with him. In terms of just imagery, we've got a couple of items that we'll share with you. If we could cue up the first video, which is from the launch of the Orion spacecraft and the Space Launch System rocket. We've got the big physics of launch on full demonstration here for you. This is the rocket lifting off from the point of view of the Space Launch System and then doing its roll off the pad, and you can see the plume heading down towards the pad and just the rocket lighting up the space coast, and it was quite a sight for those that got to be there and feel it. You got to feel it in your bones. It was a remarkable launch. The next video that we've got for you is of the Orion spacecraft looking back at itself while it's mated to the interim cryo propulsion stage. And there's a bit of an Easter egg in this video, too. If you look in the top center, you can actually see the core stage after separation below it. And this is one of the solar array wingtip cameras looking back at the main body of the interim cryo propulsion stage, as well as the spacecraft adapter. And then the aft half where the avionics ring is and the RL-10 engine is just off to the screen to the right. But to me, this was just a remarkable photo because we are some 975 plus miles in altitude here, and you see the core stage falling away back towards Earth, and this was just a remarkable video as well. And then the last one that we've got for you is of the solar array wings articulating for the perigee raise maneuver. And this is Orion looking at itself, and you can see the Earth below the spacecraft. We position the solar array wings to the load-bearing configuration for the perigee raise maneuver, and then we had the load-bearing event, and then we reconfigured them back and fully articulated them to the sun-pointing position. So these are just a few small highlights of what we've seen in the 3 short flight days, and it's been a remarkable mission to date, and we're proud to share all of this with you. So with that, I'll hand it back to you, Sandra.
Thank you so much, Mike. Beautiful imagery and photos, certainly. So next up, we'll hear from Flight Director Jeff Radigan.
Well, I got to tell you, it's a great day to be in the control center anytime we're flying a spacecraft to the moon. It's just a lot of fun for all of us that are operating the vehicle and checking it out, putting it through its paces. Today, the team was out doing the survey of the external of the crew module and the service module, using the Orion cameras to take a look at every inch of the vehicle that we can see, really check out and see how the exterior surface of the vehicle is doing, which of course leads to some of the video and pretty pictures that Mike was showing earlier. Of course, the team's preparing for the outbound flyby, and the OPF maneuver that's coming up. We've got a couple of trajectory corrections before we get there that we'll do over the next couple of days. And then, of course, we'll do the burn 70 nautical miles off the backside of the moon for about 2.5 minutes. And the burn will really put us on our way to the distant retrograde orbit, which is where we're going to continue the checkout of Orion. All of us will really be looking to receive data since the burn is done on the backside of the moon. And we'll lose comm with the vehicle for a little bit of time. It'll autonomously do the burn, and then we'll pick data up and see how Orion's doing. That'll lead us to actually 4 days later, where we'll do the DRI burn, the distant retrograde insertion, which is what really is the final step of putting us into lunar orbit. And that'll be another 1.5 minute burn that Orion will do and drop us off into the orbit, where we'll continue to check out Orion. So you probably hear it in my voice. It's very exciting just for us in mission control. It's been a very exciting mission. As Mike said, there's been a couple of anomalies we've had to work, but overall a very clean mission, and we're really having a good time. Thanks, Sandra.
Thanks so much, Jeff. And next we'll hear from Jim Geffre, manager of Orion Vehicle Integration.
Yeah, thank you, Sandra. Wednesday was quite a stunning event for the entire team. It was a fantastic performance by the rocket to deliver Orion to space. And it's been a really exciting few days for both the team and the spacecraft as we learn how this system operates in the deep space environment. It's a good reminder that this is the first time in 50 years that a human exploration spacecraft has left low Earth orbit and been sent to the moon. As Mike said, Orion's been performing great so far. All the systems are exceeding expectations from a performance standpoint, and we have full mission functionality with the upcoming outbound powered flyby burn. The team's been able to gather a lot of great data to learn how those systems are performing in space. No ground test is a perfect representation of flying in the real environment, and so we've been able to collect this data, use it to update our models, understand how the system is trending, and make decisions for our upcoming mission events. As Jeff said, we have the big burn coming up on early Monday morning, but before we do that, I wanted to share a couple of additional videos of how the system's performed on the way to the moon. I believe the first video we'll show is the separation of Orion from the interim cryo propulsion stage. Once the ICPS finished its job and sent us on through the TLI, Orion fired its pyrotechnic frangible nuts and separated from the ICPS. You can see in this video as we slowly drift away from the ICPS and head off to the moon. On the next video, we'll see how the solar arrays have been articulating during the deployment event. There's 4 different solar arrays on board Orion. Each are about 4 meters long, and one of the things we've already learned from the mission is that we're collecting more power than we expected. Altogether, we have over 13 kilowatts of power that can power the equipment on board. The deployment went great, and as you saw earlier, we were able to put those into position for the TLI burn. Other systems have also been performing fantastically. We've had better than expected heat rejection. We're using less power than anticipated. So all these things are giving us good confidence in being able to move forward with the mission and also expand our capabilities as we go forward. So with that, I'll hand it back to Sandra.
Thank you, and thanks to our briefers for those initial remarks. So as a reminder, we will be taking questions on our phone bridge as well as from any media here in the room. So if you are on the phone bridge, press *1 to submit your question and add it to the queue. And once your name is called, please state your name, affiliation, and to whom you'd like to direct your question to be answered. And if you do find that your question has already been answered, you can press *2 to withdraw it. So let's get started on our phone bridge. We do have several questions coming in already. And our first question comes from Marcia Dunn with the Associated Press.
Oh, hello. My question is probably for Jeff. How long will you be without communication when you're doing that burn on the backside of the moon? How stressful, tense do you expect it to be before you get the data? And is there much wiggle room in case the burn doesn't go exactly right? What happens then?
Well, I'll start with the stress piece. I'm sure we'll all be waiting as intently as we can, looking for the data to come back. It'll be about 34 minutes that we won't have comm with the vehicle, and so I'm sure we'll all take a little break and then come and sit and wait for the data to come back. This is absolutely a critical burn. It's one that Orion has to perform. But of course, it's got the OMS engine, which is the primary way of doing the burn, as well as additional auxiliary engines, such that if we have an issue with the OMS engine, the auxiliary engines will pick up and complete the burn. And we designate it as critical, which is why we configure the software to ensure that that burn happens. And there's a couple of those in the mission that we have. The vehicle's going to do a great job, and it's going to burn that burn, and we're counting on it to do so.
Great, and it looks like we do have a question here in the room.
I'm not sure who this is for, but are you getting any data back from the mannequins that would tell you what the ride would be like for humans?
In terms of in the course of the mission, the short answer is no. All that is recorded on board, correct, Jeff?
Yeah, that's correct, Mike. So we have several radiation experiments on board. We have been able to collect some data from a few of those, but with respect to the mannequins, that data is being collected and will be analyzed after the mission.
I know we're not going to get a lot of video Monday, or will we? And if so, when would we get it? Are you expecting any video from the close approach?
As you've already seen, we have cameras on board, a number of cameras, including on the tips of the solar arrays. And so after the conclusion of the outbound powered flyby, once we reacquire comm with Earth, we are expecting to provide some good imagery.
We all can't wait to see that. Okay, next up is Robert Perlman with Collect Space.
A question for Jeff and a quick one for Mike. You mentioned that the burn's going to occur on the far side of the moon. Do you know what notable craters or how we could orient where Orion's going to be in relation to passing over the moon at that point? And then for Mike, since you mentioned it, it's been the number one question we've gotten from our readers. You mentioned you saw Snoopy. When can we see Snoopy?
You want to go ahead, Jeff?
Sure, I'll take the first part. So we will be passing over, some of the Apollo landing sites. Unfortunately, I don't have the craters off the top of my head, since every launch date has its own different spot that we would be doing the powered flyby. So I can't reference those to you, but I do know we'll be going over the Apollo 11, 12, and 14 sites, or close to them. Unfortunately, they're going to be in the darkness. They will not be sunlit, so we won't get very good video of them, but we'll definitely be close to history when we do the powered flyby.
Yeah, and Robert, thank you for your question. Certainly, the partnership with the Schultz Foundation and their commitment to NASA is part of our flight safety program is something that we cherish, and having Snoopy on board the Orion spacecraft to the moon again is something that is exciting for all of us. As far as when the Snoopy sighting will occur, I would say in the next day or two. I don't have an exact time for the acquisition of Snoopy signal, so we'll just have to wait and see when the images are released, but it's not far off.
Our next question comes from Joey Roulette with Reuters.
Thanks. I just had a quick question for Mike, Sarafin, or anyone else who wants to answer. Back just before liftoff on Wednesday, you guys announced that there was kind of a new risk with the RTV delamination issue and involving like a sensor coming loose and becoming debris. And I was going to ask this on the last press conference, but when did you guys discover that risk? Were you aware of it Monday during the launch rationale briefing, or did you guys not know about it and actually just discover it before liftoff? Thanks.
Joey, thank you for the question. We knew about the RTV delamination due to the hurricane pretty much the day after when we did a walk down and a pad inspection. It took the team a little bit of time to do the full just assessment of the vehicle, and that was one of the findings that came back. And we went into a debris transport and just kind of acknowledged that there was a risk there. And relative to the launch attempt, when the risk was brought forward, it was clear that we needed a little extra time to develop that flight rationale, which is why we met on launch minus 1 day to understand the risk, have it characterized relative to other known risk, and so the story, was it was a first story the day after the storm passed, and we did our pad inspection, and then we knew that there was an issue out there that needed to be worked. It took a couple of days. It basically took the weekend for us to work, and then when we initially heard the flight rationale, we decided we needed a little more time to develop that. So I hope that answers your question.
Our next question is from Kristen Fisher with CNN.
Hi, thanks everyone, and congratulations so far on a successful mission. My question, since I'm kind of representing the TV side of things here, I'm hoping somebody can go into a bit more detail about what we can expect with this closed flyby on Monday morning. You say that the video is going to be delayed. Can we get a more approximate time frame as to how long it's going to be until we're going to actually get to see this video? What sort of quality is the video going to be? And finally, can you just kind of explain why we're not getting to see these images live? I mean, I believe the Apollo 11 landing was broadcast live. Why now don't we have the technology to see all of this live? And pardon my ignorance there. Thank you.
Sure, happy to talk through it. So there is video that comes down from the spacecraft that we get here live in MCC that we were able to see coming directly off the video. And some of the videos that we've shown previously in this briefing, those came down live and we saw them as they were happening, and they were a lot of fun to watch. Specifically related to the outbound power flyby, since it occurs on the other side of the moon, we've actually got the moon between the spacecraft and the ground stations that pick up the video. So we're going to record it while the Orion's out of the line of sight of the ground stations that bring the video down. Once we have that recorded on board, when we reacquire signal, when Orion comes out from behind the moon, we're going to downlink that video as fast as we can. Unfortunately, given the distance that Orion is and the fact that we do have some fairly high quality video, it's going to take a little bit of time. For those of us that remember the days of dialing into the internet on modems, it's going to be a little slower than we might have want. But as soon as we get the data down, I'm sure our video processing folks will be processing that so that we can get it out to everybody that wants to see it. Because, of course, we want to see it in mission control and we want to share it with the public and get it to you folks as fast as we can.
Thank you. Our next question comes from Chris Davenport with The Washington Post.
Hi, thanks so much. I think this first one is for Jeff. I'm just sort of curious about the speed of the vehicle. Obviously, it's been slowing down the closer it gets to the moon. What will its velocity be, sort of right before you do this burn? What will it be? What will its peak velocity be after the burn as it enters into the orbit? And then once it's in that distant retrograde orbit, is the velocity constant? And then for Mike, just real quick, there was some talk or concern that maybe there was some damage to the pad or the mobile launcher after liftoff. I'm just wondering if that's accurate, and if it is, what was the extent of the damage? Thanks so much.
So I think Jim's going to take that one.
Yeah, thank you for the question. First, with respect to Orion's speed at the time of the OPF, be about 1.5 kilometers per second relative to the Earth. Apologize for the metric units, so we'll have to do a conversion there for you. But as Jeff said earlier, it'll be a 2.5 minute burn, 2.5 minutes. In that, we use about 2,900 pounds of Orion's initial propellant load. That's about 20% of the total load that we start the mission with. So relatively short burn, but it is one of the 4 big ones that we perform as part of the mission.
Yeah, and Chris, and thank you for your question as well on the pad. The team is currently working through the pad post-launch inspections. There are a number of hazards out there that they're working through. We did anticipate some amount of damage, and they are finding some amount of damage. Again, the vehicle produced 8.8 million pounds of thrust at liftoff. We did, for the very first time with a rocket of this class with solids, have a ignition overpressure and sound suppression system in place. So, if you recall watching right at that initial, the final seconds before liftoff, there was a huge amount of water that came from that water tower that sits within the pad perimeter, and all that water came out of that tower, went down the pipe, across, and up through some piping into the surface of the mobile launcher, and that was purposefully there to dampen the acoustic shock as the rocket lifted off, because that can come down and bounce back up towards the rocket. So that water was there to dampen the acoustic shock, to largely protect the rocket. We couldn't put water everywhere on the mobile launch tower. The umbilicals did fine. The structure itself did fine, but we are finding some damage. For me, the most impressive photo that I've seen from damage was the blast doors on the elevators were removed through the pressure wave of the rocket, and they're having to restore that functionality with the elevators. So there are a number of findings, and because of the inconvenience, now we don't have elevators functioning at the mobile launcher, and it is a very tall structure. Folks are having to walk up and down it, and it's taking them a little extra time to get through it. But that said, the mobile launcher itself performed well. We just are having to work our way through some of the damage assessments, and it's taking us a little longer.
Thank you both. Our next question will be from Marcia Smith with spacepolicyonline.com.
Thanks so much. I think this question is probably for Jeff. I'm wondering, how many burns are there altogether of the arms and of the auxiliary engines? And separately, perhaps for Jeff or for Mike, where did the core stage come down? And did you get any visual sightings of it?
So I'll talk about the 4 major burns that we have on Artemis I. Of course, we've been talking about the outbound powered flyby as well as the distant retrograde insertion. After we do a half a loop in the distant retrograde orbit, we'll then do a distant retrograde departure, and then we'll do a return powered flyby. And so those are really the 4 major burns that we use the OMS engine for, to get Orion into orbit around the moon and then to bring it home after we complete the half rev there. We do have some smaller correction burns. I think there's 12 or so of those that we do, but they're much smaller. We use the attitude maneuvering jets. So you can really think of it as 4 major burns for the entirety of Artemis I on Orion.
And Marcia, again, thank you for your question. In terms of the core stage disposal, if you recall, we inserted the insertion altitude was a 975 by 16 nautical mile insertion altitude. We do have to loft the orbit with the Block 1 of the Space Launch System, which we will have an upgrade with what we'll call Block 1B with the enhanced upper stage starting with Artemis IV, where we don't have to loft. But because we have to loft with the interim cryo propulsion stage in order to have enough performance to make our way to the moon, we lowered the perigee to 16 nautical miles, which is going to get Earth capture, and the core stage certainly did that. It came down in the Pacific east of Hawaii and to the west of the West Coast. So well away from any human human presence, and it's safely splashed down in the Pacific Ocean.
Our next question comes from Jeff Faust with Space News.
Hi, question for Mike Sarafin. I'm just curious if after a couple of days you've got any more information on the performance of the SLS, how it compared to what you expected with both the core stage, the boosters, and the ICPS. And then also on the CubeSats beyond Luna HMAP, which CubeSats have you been informed are working properly so far? Thanks.
Yeah, Jeff, thank you for the questions. SLS performance, I have not received an update since we had our quick look on day of launch. You're a day too early for that question. We are going to get a performance outbrief tomorrow on the Space Launch System, the core stage, the boosters, and the interim cryo propulsion stage. But again, all indications were the system performed spot on. And as I said in the post-launch press conference, we came very, very close to the predicted insertion altitude, and then translunar injection was exactly where we had intended. But we should have more information as part of a post-launch assessment and a performance review that we're going to do tomorrow afternoon. In terms of the CubeSats, you wanted to know which others were successful. Argo Moon, which is a partnership with the Italian Space Agency, BioSentinel, which is basically an analog that's flying some yeast to measure radiation. Equilus, which is a partnership with the Japanese Exploration Agency, Luna HMAP, and then I believe Omotenashi, which is another Japanese Exploration Agency CubeSat, are on a path to success. The remainder, as we've had reported from our payload partners, either have encountered technical issues post-deploy, or have had intermittent communications, or in one case did not acquire signal with their communication asset that they had planned. So, we're working with our payload partners to the extent we can, but and we're being as transparent as we can here. But if you want to understand more thoroughly what each of the payload customers are seeing, I would reach out to those individually.
Our next question is from Irene Klotz with Aviation Week.
Disbanded, but was there any operational changes or any impact to the mission from that? And when was that team called together?
Hey, Irene, we missed the first part of your question. Can you repeat it for us, please?
Sure. Can you hear me all right?
Yep, we got you.
Thanks. Yes, it's for Mike Sarafin. The issue with the Star Tracker, when did that occur? And although the anomaly team has completed its work, were there any operational changes or any impact to the mission itself? And I have a follow-up.
Okay. Yeah. Thank you for the question, Irene. That's a good one. The anomaly resolution team, as it pertains to the Star Trackers, we got together as a team the afternoon of the 16th, which was it was a 5 p.m. call, so some 12-ish hours after launch, and we knew that there was just some anomalous performance in the Star Trackers, and it took the team some time to work through it. And the Orion program, and one gentleman in particular, Ryan Proud, that led that anomaly resolution team, did a fantastic job of researching all the potential causes. And what we determined, it was not the hardware. The hardware was operating exactly as it was designed to. It was actually an environmental situation where the thrusters were being picked up by the star tracker because it was actually thrusting over the field of view of the star tracker by design, and the light was hitting the plume and it was picking it up, and it was having a hard time understanding, was that a star or an object out there that I should track, or maybe there were objects in the field of view when it thought there shouldn't be, because the star trackers are programmed to know where the stars are, and it was essentially confusing the star tracker, and we continued on both star trackers 1 and 2 to get what they call a component not ready flag. So it took us a little bit of time to work through that one. The star trackers were gathering data throughout, and it was just one of these episodic things that took some time to resolve. The team correlated it to thruster firings, and it just took a little bit of time to do that. In terms of operational changes, there are no operational changes. We are proceeding, and that was one of the outbrief recommendations today from that anomaly resolution team as we sunset that team, was to consider the star trackers operating normally and to proceed based on that information. And Jim, I don't know if you have anything to add to that. It was under the Orion program.
Yeah. This is one of those examples of being able to learn from flight testing. You can never simulate the combined environment of plumes and Earth shadow or Earth sunlight and refraction of light into star trackers perfectly on the ground. But we fly and we find these things. As Mike described, the team pounded flat every possible explanation. We think we understand exactly what's happening. The star tracker itself is performing perfectly. We've ingested over 380,000 measurements into the navigation filter. Everyone's been accepted without rejection. So we're very confident in moving forward, and we'll proceed with the decision to proceed with the OPF tomorrow.
Thank you.
The question was about the ITAR issue at 39B. What was the situation or the configuration that prevented, I guess, the photographers from going out and picking up remote cameras till today? I guess they were told that there was some ITAR considerations. And then also, I just wanted to make a comment in light of the anomaly resolution team, and it sounds like it was an interesting episode, but that information hasn't been included in any of the updates that were posted so far. And you all talk so much about how important this mission is, and that it's the first human spacecraft in 50 years, and your number 4 of your objectives is public outreach. I would just request that whatever you can do to provide more detailed and more timely status reports of the mission, even if things are not all knit together and here's the outcome. It's really important to us to kind of be able to follow along as these things are happening. Thanks.
Okay, thank you, Irene, and I certainly understand your feedback on the star tracker, what I'll call glitch or anomaly. That one was not a high-level concern. It just was one of those what I'll call confusing discrepancies that took us a little bit of time to work through. But I certainly understand the feedback there. And in terms of the ITAR issue, I am not fully up to speed on the issue at pad 39B. But what has been shared with me is that the mobile launcher has flight interfaces on it that are considered export controlled, and not all of those are in a configuration that are ready to be photographed and shared. And there's some amount of work that needs to be done to get those in a configuration. And prior images that have been shared were either shared at a low enough resolution where that was not an issue, or were shared such that the umbilical interfaces were not in a full view such that they were export or ITAR controlled. So that's my understanding of it. I am not an ITAR expert, but that's what I know on that particular topic, and I understand why you're asking, and I would just ask for your patience as we work through that one.
Thanks, Mike. Our next question comes from James Hillhouse with americaspace.com.
Thank you, guys, for holding this briefing. I have a couple of questions. I guess the first one is, what is Orion's velocity going to be at the equigravisphere, I guess where the Earth and the Moon's gravity are equal? And the other question has to do with the smaller correction burns you mentioned. Are those being done by the auxiliary engines on the ESM or the ESM's reaction control thrusters? Thank you.
Yeah, I'll take that question. First of all, we don't have the exact velocity at the sphere of influence. We know it's approximately 35,000 miles from the Moon, where Orion will then become under the primary influence of the Moon's gravity, but we don't have that exact figure available to us at this point. I can tell you again that the outbound powered flyby burn, Orion will be traveling at 1.5 kilometers per second relative to the Earth. With respect to the correction burns, we've performed 2 of those to date. The first, which we call OTC-1, or Outbound Trajectory Correction 1. This one was done as a checkout of the OMS engine. The big 6,000-pound engine was executed perfectly. The second burn, OTC-2, was small enough that it could be performed by the small reaction control system engines, but we also have auxiliary thrusters on board. And the software makes that determination based on the size of the burn that has to be done. It picks the most efficient engine to use for that. We have 2 more of those coming up, OTC-3 and OTC-4, before we arrive at the Moon.
Great. Our next question comes from Bill Harwood with CBS.
Yeah, hi, guys. And first of all, just off the top, I'd just like to say I completely agree with Irene Klotz's observations. You know, the star trackers, I thought the flight rule required 2 operational trackers for a full duration mission. And so, I totally understand it's been resolved. I just would have thought that was a potentially more significant issue, but obviously not. Anyway, Mike, you said hazards at the pad. What does that mean? I mean, I'm not looking for a detailed assessment, but does that mean like debris somebody could trip over, a commodities issue, power lines down? I mean, any little details you can share? And for Jeff, you said 70 nautical miles at close approach. I saw something else that it was 70 statute. I just want to make sure I'm doing the right conversion. Thanks.
Do you want to take the mileage thing? I'll take the rest of it.
Sure. So the best information I have is 70 nautical miles. And I think that's really what we do our trajectory planning in. So that's the number I would use. Of course, I'll happy to be double checking with my flight design folks, who I'm sure will call me after this press briefing if I didn't get it right. And but 70 nautical miles is the distance that we're planning to, and that I have in front of me. I do want to address the star trackers real quick, in that we never had a case where we violated the flight rules. The star trackers were functioning sufficient that we could continue on with the mission. It was really a case where we were seeing something we didn't understand. And so you are correct that we do need the star trackers to continue on with the mission, but at all times they were providing us measurements that were able to allow the mission to proceed. And so while we saw something we didn't quite understand, the hardware was operating sufficiently that we were able to continue the mission. And of course, we talk in what if it doesn't work, but in this case, it continued to work sufficiently well enough for us to continue on while the team really investigated what was going on at the time.
Yeah, and Jeff, I think you hit the nail on the head there. We were meeting the functionality requirements for attitude updates and navigation updates with the star trackers. So from a system performance and system functionality standpoint, that one was not violating the flight rule. It was, again, something that we didn't fully understand, and we needed to get a brain trust together to work through it, and it didn't take that long. That said, I understand again the feedback, Bill, and apologize that that we didn't share that sooner. This is a bit of a marathon in terms of launching from the Kennedy Space Center, getting safely through translunar injection. We provided an update to each and every one of you after launch, and that was after a very long day. And then I'm speaking for myself. I think I went and took a nap at the hotel for about 3 hours, and then was notified that we had a funny with the star tracker. We did note that, and then I believe we noted that, and then we had the anomaly resolution discussion the afternoon of the 15th. Again, I'm speaking for myself. I took a power nap, and then got on a plane here to Houston the next day, and then we settled in and we worked our way down the funny list, and that was on the funny list, and we had over a dozen funnies on the list. So we are proceeding, given the information that we have, and that was not seen as a hard constraint. It was just something that we just didn't understand. It was initially outside of our experience base, but again, understand the feedback on that one. In terms of hazards at the pad, there were some gas line leaks that are used to inert the system, both on the nitrogen and the helium side. Those in of themselves are hazards, right? There's asphyxiation, and we need to worry about those types of things. But simply having some amount of damage and the inconvenience of not being able to fully assess the mobile launcher, given the elevator blast door issue, is something that's just causing us to take a little more time. So the team is proceeding out of an abundance of caution to get the full system status for the mobile launcher, and they're working their way through that. I would just again ask for a little bit of patience as we work through it. It's been 2 days since we launched, and it's just taken a little bit of time.
We have time for just a couple more questions this evening. Our next will come from Sophie Sanchez with Cosmic Chicago.
Hi, thank you. This question is for Mike. Sorry to, go on about the star trackers again, but you mentioned that the issue being with the thruster firing. I understand that the software is working, but do you expect the dazzling to be a recurring issue as you continue to use the thrusters? I mean, just going forward in future missions, they're going to rely on these star trackers. And then if you can tell us, where are the two star trackers located on Orion in relation to each other and the thrusters? And just, a follow-up question on that. On media. Is there going to be any more engineering footage from the launch offered? And, we've been expecting more views, not only of the mission, but also from the launch pad. Thank you.
I'll split the star tracker question, Sophie, and again, thank you for your question. We do expect this to be a normal phenomenon with the star trackers. It just it was something that we didn't initially understand, and it is a normal feature of this specific configuration of the Orion spacecraft. Jim, do you want to talk about kind of the orientation and just how the system is configured, and then I'll talk about the more media release.
Sure. I'll just add a few more words about how the software works. So the star tracker is constantly outputting its attitude knowledge, and the onboard software of Orion is looking for that information. Occasionally, when we see this dazzling phenomenon, the software may get a flag or generate a flag saying, I'm not ready to incorporate that data into my navigation filter. Now, this is a temporary situation. The star tracker keeps trying to acquire attitude knowledge, and when it's ready, it then clears that flag, and the software is able to reset and keep going. So this is a phenomenon we will expect to continue periodically throughout the rest of the mission. However, as we've moved away from Earth, we've seen less occurrences of it. But the system and the software is set up to deal with that and continue generating attitude information just fine. As for the location, on the aft end of what we call the crew module adapter is what's called a navigation base. Here we have two star trackers mounted in 90 degrees apart, as well as the optical navigation system, which is a different camera is used to help navigate through deep space. So these cameras, the star trackers and the optical navigation camera, are located at the aft end here. And if you recall the orientation of the service module, there are pods of reaction control thrusters oriented throughout 90 degrees apart. One of these pods is located pretty close to the star tracker base, and that's what is causing the dazzling phenomenon. But it's a very tightly packed orientation. We have radiators and star trackers and many other equipment on that service module. And so this is just something that teams have seen in past spaceflight, and we're prepared to deal with it with no impact to the mission.
Yeah, and on the orientation, Sophie, I'm sure we can follow up with you after the fact and show you a 3D model or show you, kind of a graphic of where the optical bench and the star trackers and the optical navigation sensors sit on the navigation base relative to the thrusters, just to kind of give you a sense of where they are relative to the overall Orion spacecraft, but also relative to each other, the thrusters and the optical sensors. In terms of more media release, yes, absolutely. We will share footage from the launch, the launch phase, the ascent through translunar injection. As Jeff was indicating earlier, we do have to manage bandwidth for any information that is recorded on board the Orion spacecraft. We do that through the Deep Space Network, and there are many, many other customers, science customers, that use the Deep Space Network, and we need to be good stewards of that resource. There is a capacity that we share there with other customers. But the data that is on the ground, we do need to go through that from a export control and compliance process. That is not something that NASA imposes on itself. That is a federal law that we, because we have dual use technology, have to comply with, and there is a process to do that. And we have folks that literally have to look through every still image and every video that's released when it comes to dual use technology that is on the export compliance and the international arms and traffic regulations list. And it is a byproduct of the type of system and the type of mission that we fly. We don't choose that for ourselves. It is just something that we have to comply with. So again, I would just ask for your patience and let us work through that process, and we will absolutely share what we can as soon as it's available. There are many, many images out there. I probably have seen like maybe 1% of them just in what little time that I've had here in Houston. But my personal focus is on working with these gentlemen and the teams that they represent to accomplish the objectives and do so safely. And we have other team members that are focused on sharing with the general public and all of you in the media what we can as soon as we can, and we're committed to do that.
And our last question in the queue this evening comes from Jackie Waddles with CNN.
Hey, everyone. Thanks so much for doing this. So, Mike, you mentioned there were a dozen or so funnies that you were working through the day after launch. Do any of those stick out as significant or remain unresolved? And then going into this decision tomorrow on whether to enter the distant retrograde orbit, what sticks out to you on that checklist, and what could prevent that from being a no answer? Thank you.
Yeah, Jackie, that's a great question. In terms of our readiness to commit to the distant retrograde orbit and the decision gate tomorrow, there is nothing that sticks out as a clear no-go or a lean against against what we've seen. Of the 13 funnies that we've seen, we talked about the Star Tracker component ready flag. We had a coolant loop 1 flow rate funny where we saw a momentary drop in the flow rate, and it's happening episodically, which indicates that there's gas in that fluid line that has a propylene glycol water mixture. We're getting proper cooling on the coolant loop 1 specifically. We've seen a number of issues with file transfers from the solar array wingtip cameras. They have memory and recorders on board. They use a Wi-Fi system to get imagery into the cockpit. Obviously, imagery, we love it. We want to share it as much as we can. We want to record it. But if we're having issues getting it off of the vehicle, that actually slows the effort to share things with the team. And Jeff and his team in the FOD team in Mission Control have worked through that. They've kind of figured out how to work through the system. And part of this is with the Deep Space Network and understanding when we have the availability to do that. We did have a number of communications glitches, some of which are behind us during the launch phase. We had either forward or return link problems, but we did capture a lot of data during the launch phase. And we've seen that the spacecraft is running a little hotter when it flies tail to sun, but it's certainly well within limits. So those and some other micro switches and brake latch indications on the solar array wings, all those, the team has documented, worked through to understand, is this a thermal thing? Is it a micro switch thing? But overall, the system is performing really well. And right now, we don't have any again, hard leans or hard no-goes against the commit point to the outbound powered flyby. But that said, that decision gate is tomorrow. There's always a chance that something could happen between the time that we're talking and tomorrow, and our risk posture and our situation could change. So we're just going to wait. We're going to give it more time. We're going to give the teams more time to assess all the data that we have and to continue to shake down the spacecraft as we head outbound and wait for that decision gate and make that decision when it's time. It's not time to make that decision right now. And I don't know, Jim, do you have anything to add in terms of the anomalies? Anything stick out in your mind that would be a hard no-go?
No, I think you characterized it very well. We're learning some things about the system that we didn't see in ground testing. But again, the system performance has, in general, exceeded expectations, and everything points to being able to accomplish the outbound powered flyby and continue the mission. Okay.
And Jeff, from your standpoint, you're one of the lead operators in Mission Control. That anything that you want to highlight in terms of our ability to enter the distant retrograde orbit and proceed with the outbound powered flyby?
No, I would tell you that the vehicle is very clean, right? We're learning things on a first flight vehicle. A lot of that, honestly, is the operators going, hey, this didn't look like the way I expected it, but then we look at it a little bit longer and we say, well, that's performance that's acceptable. It may not be what we expected, but it is acceptable performance and it allows us to proceed. So there's a lot of that learning that's going on. And, right now, all the systems are meeting all of our flight rules to press for OPF. As Mike mentioned, the MMT will make that decision tomorrow, but right now we're looking good and we're ready to go continue executing.
Yeah, so I think what you're hearing here, Jackie and Irene and others that have asked some of these questions, is we had an understanding of the system headed into the mission. We had predicts. We had, whether it was how much power we would consume or how much propellant or how hot the vehicle would be. And we're not exactly matching that. And in most cases, it is performing better. We're using less power. We're using less propellant. It's a little bit warmer than we thought it would be, so maybe we don't need the heaters as much. We're seeing things that don't quite match our predictions. And the team is spending the time to go through that and doing it with a fine-tooth comb to make sure that there isn't something else there that is potentially a latent issue or something that would give us concern as we're sitting out there in the distant retrograde orbit. You got to recall that the distant retrograde orbit is a non-Earth return trajectory. We're deliberately going to put ourselves in an orbit about the moon and stress test this vehicle. So before we do that and before we commit to it, we're going to look at every rock. We're going to turn every rock over. We're going to make sure that we understand thoroughly what each of these things mean that don't match what we were predicting. And that's what you're seeing and that's what you're hearing.
Great, thank you. And thanks to all who submitted questions this evening. And a huge thanks again to our briefers for taking time out of their very busy schedules to discuss the upcoming outbound powered flyby burn and entrance of Orion into the lunar sphere of influence. We'll be covering the OPF burn live on NASA TV beginning at 6:15 a.m. Central, 7:15 a.m. Eastern on Monday. And be sure to follow along with our daily blog posts as Orion continues its journey to the moon and beyond at blogs.nasa.gov/Artemis. So thanks again for joining us. That will wrap up today's briefing.